Hey everyone, this is Mayur. Welcome to ML Works. In this video, we'll try to implement linear regression using PyTorch. PyTorch is a deep learning library which is used for building complex models like what we have seen, like ChatGPT and diffusion models, convolution neural networks, all those kind of models we can build using PyTorch. And building linear regression using PyTorch is kind of what overwhelming because linear regression we already have many libraries like scikit-learn which has already these algorithms built in it. But the reason for doing this is we can learn PyTorch by implementing simple algorithms like this and the flow the PyTorch has to go through while building a model in general. Okay, so let's get started with building the model in the first place. So first thing is we'll be importing the packages. First is we are importing Torch, and then we'll implement the NN module from Torch, and then we are also importing NumPy. So next step is to build a dummy data set which is compatible with Torch. So Torch requires tensors, so we have to convert our data set, whatever it is, like either it's a data frame, pandas data frame, or NumPy array. We have to convert it into PyTorch tensor. So what I'll do here is I'll just create a list. Okay, for I in range of 20, then y is equal to, this is a simple equation which we'll try to learn using neural network, 2x of xi plus 10 for I in range, not in range, in x. So we have our x and y. Now we have to convert that into torch tensor. For that, what we can do is torch.tensor, pass our x here and given our floating type. The reason for giving this d type is when you are calculating gradients for a particular parameter, it requires you to have that particular variable to be of floating type. Okay, so that is the reason we are giving this as float 32. And also while training this model, or when the way PyTorch works out is it requires in terms of multiple dimensions. Okay, so this is like we have to reshape this particular list into a format which is compatible with Torch tensor. So we have to reshape this into multiple dimension. Similarly for y train. So we have this x, we have y. So we have done this one. Let's check out what it is. X train should be 2 dimension here. Y is also 2 dimension. Yep. Okay. Now let's build a class for linear regression using NN module. So linear regression NN.module. Now init function self comma. Okay, linear regression will take in two inputs. One is x and one is y. So we can pass that as input and output here, and then we can build a. Okay, one more thing is we have to, since we have inherited NN module, we have to use super keyword here to make use of NN module. Okay, so self.linear is equal to NN.linear input comma output. Okay. Next is forward pass. We have to make self comma x, y is equal to self dot linear. It will take in x and it will return y. So we have built our simple linear regression here. Next is we will initialize the model here. Linear regression, the input dimension and output dimension. Then we have to use optimizer to update the parameters of linear regression. So for that we can use torch.optim.std. So we'll use stochastic gradient descent algorithm for updating the parameters of our model, or means our features parameters. Okay, std, and we have to pass our model parameters, and then we have to give a learning rate as well, which is 1e minus 5. Okay, next is loss function, which will help us in understanding if our model is performing well or not. The loss should keep decreasing as we iterate through our model. The dataset iterates through the model. Okay, loss function is equal to nn dot. For linear regression, we'll use mean squared error. Okay, so we have initialized all these three functions here. Now let's train the model. So we have to pass our data set through a model over a number of times, like iterations. So we'll start off with epochs is equal to 100 for I in range of 100, I plus equal to 1. So we have to take our input, which is x train dot. So we have to calculate the parameters for this particular input. So we have to give required, okay, required grad. So we have to pass this here, and then for label we have y train. Okay, so once we have initialized this, then we have gradients for this x train. So we have to first initialize it to 0. So what we can do is opt dot 0 grad. We'll initialize it to 0, all the parameters. Next we'll be calculating the output by passing it to the model. The input is passed to the model, we get the output. Now this output is how much it differs from our ground truth, which is y train. So what we can do is loss is equal to loss function of output comma label we have here. It's nothing but y train. Output is it's a predicted from model, whatever, based on the input. Okay, so once we have our loss, we have to update our parameters. So for that we have to go through the backward propagation. So loss dot, not loss, yeah, loss dot backward. Okay, then we have to update the parameters here in the optimizer. Next we can print for each epoch what is the change in loss. So epoch is equal to I, and then loss is equal to loss dot item. So let's see. So we have, what we have done is, first we are iterating the data set through 100 times through the model. Okay, so we have also enabled the grads here, requires grad, and which will be getting updated here in these steps. Okay, let's run this. So for first epoch we get about loss of 647, and as we iterate over this particular model, so from 647 to it goes to about, for 100th epoch we go to around 404. Now the thing is, we have to see what is y train first. So y train is, we have these values 10, 12 and till 48. This is based on our function which we have written at the top, which is y train is equal to 2x plus 10, I guess. Yeah, 2y plus 10. This is based on that we are getting these values here. Now since we have trained a model on this, we can do a prediction. Y pred is equal to model dot, not model dot, it is x underscore train dot requires grad. Okay, let's see how it works out. Okay, type error, so it should be a tensor, right? Okay, let's see. I think this should work. Yeah, so this should work. So y pred, so what we are seeing here is, so the value, there is a difference between what we predicted and what is the ground truth. So it is 0.6 instead of 10. Okay, so we can retrain the model for about 1000 epochs instead of 100 epochs, right? We can move it to 1000 epochs, and we can reduce the loss by that way, right? We can also reduce the loss. So what I'll do here is, if I percentage 100 is equal to 0. So just to notice here, right, what we are seeing here is our loss is at around 404 even after 100 epochs. Okay, so we have to reduce that. So we are going for 1000 epochs. So I'll change here, instead of 100 it should be 1000. Yeah. Okay. After 1000 epochs the loss is about 25. And now if we predict on our training data, so now if you see here, Though for what for instead of 10 we got, so that didn't change much. It from 0.62 it became 0.8. But if we go around here for values about 20, for white train of last few values, it is started matching, it started converging here. It is predicting properly for these values. Okay, so one thing what we can do is we can still improve that. I guess we can do this 5000 epochs or 2000 epochs, and this will be around 200, I guess. Okay, okay, from 25 it became 21. Let's see. Okay, from 0.8 it became what, 0.96. But if we see here, this is also changing, so we have to optimize in such a fashion that the error is less, MSE is less, and the estimation between the ground truth and the actual value, it should also be what reach, should be minimum. Okay, so we have to optimize that. But anyway, we what we have learned here is we learned how to what write a model like class here for linear regression, and we used NN module for that. And then we initialize optimizers and loss functions, and how to what arrange them in such a way that first the gradients are 0, then we give our inputs to the model and we get the outputs, and then we calculate the loss between our input and the label, loss between our output and the label. Based on that loss, we update our parameters again here. So another thing, right, instead of changing the epochs, you can also update the learning rate. What I'll do here is 1E4, and then we'll try to run this model again. Okay, so now for 200 epochs, 2000 epochs, from 21 it became 18.5. Okay, let's see what it gives. Okay, now we are getting around somewhere 1.7. Okay, okay. So thus we have to experiment like this, like we have to change the learning rate or the number of epochs, and use a different optimizer if required. And we can go ahead. Yeah. So I hope you managed to learn something out of this particular video. We learned some basics of PyTorch, how to use that. I hope this particular video was helpful to you, and if you do want to understand more about PyTorch, do subscribe to the channel, and as I'll be posting more videos on PyTorch going forward. Thank you.